Chapter 4, review number 59. The coordinates of a particle moving in the plane are differentiable functions of time with dx dt equals -1 meters per second. Dx dt equals -1 meters per second. And dy dt is -5. How fast is the particle approaching the origin as it passes through the point 5, 12? Alright, so we've got the origin right here. We've got 5, 12 right here. This is 5, 12. And it tells us that dx dt is -1. So the horizontal component of the velocity of this particle is -1. It's going -1 in the horizontal number line. Dy dt is -5, so that means it's going down at 5 meters per second. So going down at down at 5. Alright, that's what we know, and that's our dx dt and that's our dy dt. We want to know how fast the particle is approaching the origin. Okay, so let's connect these two, and I'll call this d. So we would be looking for dd dt. How fast is that changing? Because that's the distance from the origin. Well, we can set up a right triangle. 5, 12, this is 13. Okay, so at this given time, it's 5, 12, 13. Those are all three variables. But at this point, it's 5, 12, 13. So let's set up, this would be x, this would be y, and we already know that's d. Okay, so the Pythagorean theorem does work here because we're given so much information to start with. We can just say x squared plus y squared equals d squared. Find the derivative with respect to time. And plug in what we know. We know dx dt, we know y, we know dy dt, we know d, and we can solve for dd dt. Now it's going to be negative, whatever we get here. I guess I'll finish the problem. So -10, well, minus 120 equals 26. So -130 over 26 would be my answer, whatever that turns out to be. Oh, 5. Okay, so I think I would guess that the book would say 5 is the answer, not -5. It'd be 5 meters per second because of the way it's phrased. It says how fast is it approaching the origin. It's approaching it at 5 meters per second.